Okay, the next set of, in our book, the next set of problems were for proofs. They call this definitions. And so a lot of these proofs, they expect you to know the definitions of certain things. And so for this one, they're saying prove that 0.13 repeating is an element of the rational numbers. So the definition that we're looking at here is what is a rational number. Okay, so there's two good ways to prove this. One of them is that we can say let x is equal to 0.13 repeating, which is equal to 0.131313 and so forth, repeating. Okay, and so then this would imply that 10 times x would be equal to, well, if I multiply this by, I lied, I don't want 10, I want 100. 100 times x would imply that this is equal to 13.1313 and so forth. Okay, and so we also know that I can say this part right here, the decimal part, was actually equal to this. So this 100x is going to be, this implies that 100x is equal to 13 plus x. That 0.13131331, whatever, was equal, we defined it at the very beginning as x. So now what I have is I've got a 99x, if I subtract x from both sides, is equal to 13, which would imply that x is equal to 13 divided by 99, and that is a rational number since we've got an integer divided by an integer. So this would imply that x is an element of the rational numbers, which implies, therefore, that 0.13 repeating, 0.13 repeating is an element of the rational numbers. So we always end up where we started. The other way to think through it deals with sequences. And so we could say, let 0.13 repeating equal, well, this is 13 over 100. Plus 13 over, well, there's 10,000 plus 13 over, and I need 1, 2, 3, 4. I need 6 zeros, 1, 2, 3, 4, 5, 6, plus dot, dot, dot. Okay, and so, and this is we could say this, a geometric series with a sub 1 equals 13 over 100, and r is equal to 1 over 100. Notice I'm adding 2 zeros each, well, multiplying by 1 over 100, which puts 2 more zeros underneath. Okay, therefore, we can say that the sum, and since this is less than, maybe we should write that. Since 1 over 100 is less than 1, the infinite sum is going to be equal to a sub 1 over 1 minus r. So that sum is equal to 13 over 100 divided by 1 minus 1 over 100, which is equal to 13 over 100 divided by 99 over 100. Multiplying both sides, we get that this would imply that this is equal to, our sum is equal to 13 over 99. Since that was equal to this sum, therefore we can conclude that 0.13 repeating is equal to 13 over 99, which would therefore conclude that 0.13 repeating is an element of the rational numbers. Okay, I will do the second one in its own video.